All right, we're ready to begin. Am I correct? Yes?
Yes.
Wonderful. Well, رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي. Good evening. Assalamu alaikum, and may peace be upon you all. I would like to welcome you to the NICC webinar titled The Legacy of Islamic Math and Science in the Modern World. My name is Duriya Nadeem Khan, and I am a fourth-year student at The Ohio State University, studying a dual degree in biology and public affairs with a minor in pharmaceutical sciences. On my way to law school, inshallah. I've been calling NICC my second home since it opened in 2006. I was 6 years old at that point. Ever since, I've been a lifelong volunteer, specifically in the outreach and interfaith department. This establishment has supported me so much so that the connections I built as part of the interfaith events helped me found a nonprofit at the age of 16 focused on youth interfaith efforts, and I furthered my civic engagement advocacy. The support from NICC has opened countless doors for me, for which I am eternally grateful. With my passion of accurate Muslim representation, I am overjoyed to moderate this collaborative effort with Kenyan college students presenting their research about the legacy of Islamic contributions to STEM in the modern world. These efforts are supervised and led by Dr. Noah Aiden, who has been a major contributor to our outreach and education committees. This activity is a civic engagement event that NICC is committed to present annually. We look forward to your participation and engagement. A little bit more info about Dr. Noah Aiden. He holds a PhD in mathematics and an MS in computer science from The Ohio State University. Dr. Aiden joined Kenyon College in 2002, where he teaches a range of mathematics and computer science courses. His primary research area is algebraic coding theory. More generally, his research interests include applications of algebra, cryptography, theoretical computer science, mathematic education, and history of science. Professor Aiden has been leading a long-term undergraduate research program in coding theory with Kenyon college students that yielded many publications co-authored with students. Professor Aiden, his colleagues, and many Kenyan students are record holders of dozens of best-known linear codes. A senior member of IEEE, which is the Institute of Electrical and Electronics Engineers, Dr. Aiden regularly reviews manuscripts for the leading journals in his area of specialty. Dr. Aiden's relatively recent interest in the history of mathematics in the Islamic world led to a multi-volume publication, which is a translation with commentary of one of the most important mathematical books in the medieval Islamic civilization. He is particularly interested in disseminating accurate information on the subject and its inclusion in school curriculum. As a resident of Central Ohio for over 25 years, Dr. Aiden is involved in interfaith activities around the area as part of his efforts to promote diversity, inclusion, equity, and respect for others. A link to last year's event is up on our main Facebook page, and today's webinar will be live on Newer Ohio's YouTube channel, and its link will be also shared on the main Facebook page. Please feel free to post your comments and questions here on Zoom, or on the Facebook event page, or Newer Ohio YouTube's channel, where our technical team will be collecting them. Your answers will be addressed and answered during the Q&A session at the end of the webinar. However, please do post them as you think of them. Dr. Aiden, the floor is all yours.
Okay, thank you. Thank you, Duriya. Thank you so much. Good evening and assalamu alaikum, everyone. Peace and blessings be upon you, with you all. Thank you everyone for tuning in now, and also those who may be watching the recording later. And I know that some of you attended this program a few times already in the past. Whether you are new to this or not, we hope that you will find this event interesting and informative. I would like to give a quick history and background for this event. So what we are having tonight is presentations of the final projects for a math class at Kenyon College. Those who may not know Kenyon College, it is a small liberal arts college in Central Ohio, located about 50 miles northeast of Columbus. If you are a high school student or if you have children in high school, you may want to visit our campus, which is known to be one of the most beautiful college campuses in North America. The title of the course is The History of Mathematics in the Islamic World. It is a unique course that was designed about a decade ago, but not because I had any expertise on the subject or I was planning to teach it, but because a colleague from another department thought that it would be good for me to teach such a course. I agreed that it was a great idea, but I didn't know anything about it. I had to learn everything from scratch, and what I learned was truly fascinating. And I learned that some of the most important and fundamental notions of modern math and science come from the medieval Islamic civilization. Everything from the numbers that we use today to the science of algebra and trigonometry, the concept of algorithm, foundations of optics, and the beginnings of the scientific method, to name a few. But at the same time, I was really disturbed by what I learned. I quickly realized that I knew so little about the subject, despite the fact that I am a Muslim scientist, I was born and raised in a Muslim majority country, and I care about these things. For example, algebra and algorithms are so fundamental in modern science in general, and for my own research in particular, but I did not know that both of these concepts have their roots in a medieval Muslim scholar. Why did I know so little about this? I realized that I was not the only one who did not know. My story was a reflection of the larger state of affairs. By and large, these contributions from Islamic civilization have been ignored or forgotten, not only in the West, but in the Muslim world as well. You will learn some of the reasons behind this from the presentations, especially from the first one. On the other side of the coin, some Muslims, vaguely know some things about these contributions, but they do not necessarily know the specifics, and often what they know may be mixed with exaggerations or false information. So for example, there is a very popular myth that Muslims invented zero. You may have heard of this, whereas true contributions are not known. As the religion of Islam demands, we should be after truth, the plain truth, no matter where it comes from. Our purpose in this work is to find out the facts based on best available evidence and communicate it to the public. Our purpose is not to glorify the Islamic civilization, but to tell a more accurate story based on best available evidence and help spread accurate information. So it turns out that there are two big needs in this field. One is academic research on primary sources, and the other is dissemination of accurate information to the general public. Though academic research in this field is still highly incomplete, we learned a lot since the middle of the 20th century. However, most of that academic knowledge did not become common knowledge. A key reason for this is the fact that most of this material is not being taught in schools. Whereas school kids learn all about Renaissance scientists such as Copernicus, Galileo, Kepler, and Newton, as well as ancient Greek scholars like Aristotle, Euclid, and Archimedes, they usually don't learn anything about equally important scholars from the Islamic world, such as al-Khwarizmi, Ibn al-Haytham, Ibn Sina, Omar Khayyam, Ibn Khaldun, al-Biruni, al-Tusi, or al-Kashi, to name a few. Neither do they learn anything about the influence of Islamic scholars on Renaissance scientists. This is despite the fact that modern researchers discovered these connections many decades ago now. It is well past the time to change this. And the Muslim community needs to do its homework. The first step is of course, to educate ourselves. And we hope that tonight's event will be an inspiration for all of us. So tonight, we are going to have 2 talks and 3 videos. The first talk will give you a general overview and describe 2 narratives about the history of Islamic science, one being so widespread but not accurate, but the other not so much known. Subsequent presentations will give you a sample of contributions to mathematics and sciences from the medieval Islamic civilization. We also have a lot of digital materials besides presentations tonight. We have a lot additional materials available for teachers, students, and anyone else who might be interested in this subject. So I would like to briefly show, share a screen. Okay, so this is my website, by the way. I invite everyone interested in this subject to contact me with questions or ideas or suggestions. And I also like to show these links that contain additional materials that can be useful for students and teachers and anyone who might be interested in the subject. So we are grateful to have this event again this year despite the pandemic. And we hope that you will find these presentations informative and inspiring. As the moderator already explained, we are going to answer questions at the end, but feel free to pose your question as they occur to you in the chat or on other platforms. And again, I would really appreciate anyone contacting me about any questions or comments or suggestions or collaboration. So this is the website for the course, and these are the links for digital materials. And this is my personal website at Kenyon College, where you can also find my email address. So now we are going to start with the presentations. And again, the first one will give a general overview of the subject and talk about the two narratives of history of science in regards to the contributions of Islamic civilization. Okay, so Kate and Sonia, can you please share your screen and introduce yourself and go ahead.
While Sonia shares our screen, I think it's this one. My name is Kate Burgess. I am a junior chemistry major, and I use she, her pronouns.
Sorry, one sec. I'm Sonia. I use she, they pronouns, and I'm a senior double major in English and dance. So ready to get started?
Yeah, I think so.
Sweet. Well, thank you, Professor Iden, for that introduction. For our presentation, we chose to focus on two narratives reconstructing a more accurate history of Islamic contributions to mathematics and science. So as Professor Iden mentioned, these presentations are taking place as part of the culminating project for this math course that we are all students in this semester. It's a really unique course, as he mentioned. I don't think there are a lot of courses like this out there, and it seeks to really fill in those gaps in the knowledge of history of math and science in the Islamic world and the contributions of Islamic and Muslim scholars in those areas that aren't often taught or disseminated, both in the scholarly world and also, I think, kind of beyond that in more popular and public spheres. So really the important thing here is disseminating that correct information, not just kind of seeking to center marginalized voices, which is of course an interesting and important task, but not really relevant in this case. And our class also included students from a really wide variety of majors and years at Kenyon. So as you'll hear through our introductions, we all kind of come from different academic backgrounds. We're all different years at Kenyon. So it was a really kind of diverse context to understand and learn about this information. So just to begin with, I think it's important to establish these two terms, the classical and the alternative narrative, which were coined by George Saliba, who is a scholar in this area in the history of mathematics and science. And he coined these terms in his 2007 book. So the classical narrative is really based in ideology as opposed to kind of factual evidence, as we learned in the course. It's really about this dominant Eurocentric narrative that's really pervasive in a lot of source material. It claims that the European Renaissance is kind of this separate entity that springs out of Europe and is kind of disconnected from any previous work. It's kind of this incredible flowering of knowledge, but it doesn't really relate to anything else. It's kind of like the Greek scholars have their kind of heyday, and then there's like a big gap, and then the European Renaissance just kind of springs up out of nowhere, which is not really correct, as we will kind of go on to say. It's also really based around preconceptions and biases that create a really self-fulfilling prophecy in relation to research in this area. So because scholars aren't aware of the kind of rich body of work that Islamic scholars contributed to, they aren't looking for it, and therefore a lot of things get overlooked. In addition, there are a lot of just blatant misattributions which occur. We'll talk about a few specific examples a little bit later on, but just blatant misattributions that completely overlook the factual evidence that is out there. And this even happens through really experienced and well-known scholars. In addition, Muslim civilization is kind of valued in certain other contexts. Muhammad might be like named as a really important historical figure, but the academic side of contributions are really completely overlooked. On the other hand, we have the alternative narrative, which is kind of something that Saliba proposes as an alternative to the classical narrative. It's much more evidence-based. It is a different, more accurate historiography that really constructs the European Renaissance as something that is in dialogue with Islamic scholars, that is in direct kind of communication with these previous scholars and their contributions. There's also a lot of specific textual analysis that goes into that. So, for example, manuscripts that have the notes of certain European Renaissance scholars on them and show that really direct communication between those texts and those scholars. It also challenges what we call classical narrative mindset, which is kind of the biased and preconceived ideas that are kind of a function of the classical narrative and lead to a lot of misconceptions. It also includes the valuing of Islamic contributions to math and science in their own right and alongside the European Renaissance. So without knowing and disseminating this information, we can't really have a full picture, and the alternative narrative seeks to give us that fuller picture. So as I discussed earlier, misattribution is a really key part of the classical narrative, and one of the most important examples of that is the decimal point. So that was actually a mark delineating the decimal place of numbers, which we use a lot in modern math today. It was originally used or conceived by al-Uqaydisi, who's pictured here in the middle, but was actually misattributed to Simon Stevin, a later European Renaissance scholar, this was kind of done by George Sarton, who's also pictured on the slide. He's widely considered the father of the history of sciences, so a super important scholar, but just due to lack of research, he managed to completely overlook this and misattribute the decimal point to Simon Stevin, which then leads to a ripple effect, because since he's such an important scholar, then his misattribution is kind of reified through later sources that also don't do their research completely. And as you can see, then that develops and kind of spirals into a much larger issue. Another example of misattribution and really erasure, I think, is the kind of conception of the scientific method, which we'll hear a little bit more about in one of the later presentations tonight. But Sir Francis Bacon and Isaac Newton are often kind of cited as the big names when it comes to the scientific method and this way of doing science where you have what you call like empirical work, where you're working based off of evidence that you find and you experiment, and you are kind of basing everything you know and do off of that evidence and off of your experimentation. However, this was actually first conceived by Ibn al-Haytham, who comes much before these later scholars, and he also made these really great strides in optics, which we'll also hear a little bit more about later on tonight.
To give everybody kind of a picture of where all of the scientists that you're going to hear about tonight sit in history and in relation to one another, we figured showing you guys a timeline would be a very helpful tool. So we're going to start in the Greek sciences around 500 to 100 BCE. And the most important Greek scientists that whose texts were translated and used for their science were Ptolemy, Pythagoras, Aristotle, and Euclid. These texts began translation in the Umayyad Prince Khalid Yazid's reign, as he asked these texts to start being translated and used for the field of chemistry and alchemy at the time. And so this started that translation period, which is significantly earlier than the classical narratives proportion that the Islamic scientists did not begin until the dream of al-Mamun, as you can see in the timeline between 800 and 900. So that's a full 150 years prior. The next scientists that we're going to talk about are al-Khwarizmi, al-Kindi, al-Haytham. You'll hear about al-Haytham in one of the later presentations. He wrote a book on optics that is very famously cited and used in making the camera obscura, which you can see in the bottom right corner. Then we see the tapering of the House of Wisdom in about 1250 at the Mongol takeover, and which at this point begins the golden age of astronomy, continuing up until the beginning of colonialism. However, while this golden age of astronomy happened through 1450, Islamic sciences are said in the classical narrative to have tapered with publication by al-Ghazali, which is around 1100. So this is much prior to the actual end of this period. And in the right corner, you'll see al-Kashi's Miftah, which our professor is working on translating, which is pretty cool. So you probably saw Al-Pascal's triangle in, I don't know, 8th grade, 9th grade algebra, but it should actually be called Al-Karaji's triangle, as he was one of the first to publish on this triangular array of coefficients. If you see in the bottom line of the phrase of the slide, a plus b squared, and you get at the end, once you FOIL that out, is what we called it when I was learning it, is a squared plus 2ab plus b squared. And if you look at the third line, as squared is technically the third power, because you could take a plus b to the 0 to get 1, a plus b, and you have coefficients of both 1 and 1, and then a plus b squared to get 1 to 1, as seen in the bottom line. However, we believe that Al-Pascal saw this array in the publication and published on it himself. However, he probably didn't properly accredit his sources and presented it as his own. And this is a complete misrepresentation of history, even though we've known that this is al-Karaji's triangle for a very long time. This is one of many instances of the dominant classical narrative covering up the true history of math and science. And so we're trying to change that. There we go. Copernicus is known as the father of modern science, similar to the father of history of science, as we talked about earlier. However, one of his most famous publications about the Tulsi couple is what we refer to it as, is really interesting in that in Tulsi's publication, which you can see on the right in slightly pixelated font, is the exact same diagram that he had, only like down to the letter. All of these points are the same. The way that he used them is very similar. And it's really helpful because it eliminates Salome's equant, which is a radius that changes length as you go around the circle. So it just doesn't make sense. It doesn't follow mathematical observations in the sky. And the Islamic scholars are very known for critiquing sources as they translated them and saying that this doesn't quite make sense. This was started by al-Haytham, critiquing these sources. He's pretty well known for it. And Copernicus copied down all of the variable names, A, B, C, D, E, except for Z, which is really interesting because Z could easily, if you don't understand Arabic very well, and I very much do not, but from what I understand, if you understand a little bit of Arabic, you can mess it up for an F, the Z character, and that's exactly what he did. So it's believed that he definitely saw some version of this drawing at some point in time.
So just to finish off, I guess the question becomes kind of like, where do we go from here? Knowing the classical narrative, knowing this alternative narrative, and understanding kind of the differences between the two and how we're hoping to kind of shift assumptions and disseminate more correct information. We looked at a lot of different sources for our research paper for this class, which also goes with this presentation. And one of the scholars we looked at, Sonia Brentius, talks about the importance of students in relation to the history of education in the Islamic world, especially in the sciences. And she basically cites students as being basically as important as teachers in that history. And I think that can really be applied to our class and the experiences that we've had this semester. So there are a lot of possibilities for shifting assumptions and disseminating correct information. This class is obviously just one of those. Professor Iden talked a little bit more briefly at the beginning of this about the digital resources that he and some of his students have developed in the past couple of years. I put the URL for that in this slide, and I'm sure we can also disseminate that in the chat and perhaps on the YouTube channel as well. But that's just one example of kind of the work that's being done and a small step in the direction of making the alternative narrative kind of the more broadly and widely disseminated and understood narrative of the history of math and sciences. And I also just want to make the point that we're only really scratching the surface here. These are very few kind of examples in the whole narrative of the history of mathematics and science. We're also focusing a lot more on math because this is a math course, but there are plenty more examples if you look for that information. And hopefully these kinds of presentations and more courses like this kind of springing up across academia, and also students and other individuals who know the kind of the truth and the accurate information, disseminating that in their own lives can be a step towards kind of making the alternative narrative the more broadly and widely known one, and hopefully stamping out misinformation once for all. Thank you.
Okay, thank you, Sonia and Kate. Again, we'll take questions later. Okay, next we have a video about one of the greatest science book in history of science by one of the great Islamic scholars. So the next group will introduce the topic. You know, they will introduce themselves and then they will show the video.
Hey, hello, I'm Alejandro Gonzalez, and I'm a sophomore here at Kenyon. I'm a history and MLL language double major. I study Arabic and Russian, as well as medieval Islamic history.
Hello, my name is Reese, he, him, his. I'm a junior here at Kenyon and a double major in classics and English.
Hi, my name is Nate Sandin. I'm a senior chemistry major. I actually just finished my last day of classes at Kenyon, so that's pretty exciting. But I think, yeah, it's important to note that like all of us, while Alejandro is getting ready to share, that all of us come from very different majors. And I think that's very telling, is that like you don't need to be a math or a history major to learn these topics. Like it's applicable in all aspects of education, not only in STEM, but in everything else. So that's pretty cool.
Yeah, to add on, throughout researching this topic, I've found that my knowledge of Arabic and Latin and Nate's knowledge of English and writing and Nate's knowledge of just STEM stuff has really helped us understand and create and, you know, bring forward the final project. So, and, you know, I think it's really a group project. I'm really proud of what we've done here. So without further ado, we don't want anything else.
No, that's good.
Okay, cool. I'll present now.
Al-Haytham is a Chinese example of the use of medieval for much of early life, Al-Haytham's financial system, like copy history for him.
Okay, Alejandro, the audio is very low. If
Oh, really? That's as high as I have it on my computer. I'm sorry. That's as high as I can do it on my computer.
Okay, try it again.
It's fine on our end.
It sounds good on our end.
How about others? Did you hear the audio?
Really?
No, right?
Oh my God. Oh, okay.
Try again. If it doesn't work, I will share from my computer. Okay.
That sounds good. Yeah.
Okay.
I'll be getting
Try one more time.
there. Okay, cool. Yeah, okay, that's an issue.
Yeah, our apologies.
Yeah, sorry about that.
Born in the year 965 CE, Basra, in present-day Iraq, Ibn al-Haytham is a shining example of the genius of medieval.
It is very low again for me.
Mm-hmm.
How about others? Did you hear any audio? I mean, did you hear it well?
Okay. Oh, I'm sorry, guys.
Okay, then. So how about, okay, me sharing.
Okay, that sounds good.
screen.
Again, our apologies
Yeah.
for that.
Okay, so that's why I have a backup for everything.
Mhm.
Okay, so I'm going to share it. Just okay. View full screen.
Born in the year 965 CE in Basra, in present-day Iraq, Ibn al-Haytham is a shining example of the genius of medieval Arabic scientific and mathematical progress. For much of his early life, al-Haytham financially supported himself by copying the treatises of thinkers before him, tutoring the children of noble families, and pioneering treatises of his own. Through copying, al-Haytham became intimately acquainted with the works of Aristotle, Euclid, and others, and it was by writing scientific treatises that his experience in scientific experimentation first matured. One of these treatises about regulating the floods of the Nile even reached the ears of the Caliph al-Hakim of the Fatimid Caliphate. Interested in al-Haytham's treatise, the Caliph sought the scholar and brought him to his court in Cairo to discuss the regulation of the Nile. After preliminary sketches, however, al-Haytham was forced to concede the impractical nature of his design and was imprisoned by al-Hakim for insubordination. It was during his time under house arrest that al-Haytham wrote his most famous work, Kitab al-Manazir, or the Book of Optics. In this work, al-Haytham used mathematics and experimental observations to examine the human visual system more systematically than anyone before him or after him until the 19th century. According to Lindgren, Alhazen leveled a devastating attack at prevailing optical theories and formulated a grand and viable alternative. Ibn al-Haytham wrote on subjects such as visibility, the perception of color, the effect of bright lights on the eye, how light enters the eye, and more. One of his most famous experiments is known as the camera obscura, in which he created a pinhole camera in a dark room, creating an inverted image on the opposite wall, thereby showing that light travels in straight lines. Ibn al-Haytham used this observation to conclude that the image in the eye is also inverted. The experiments of Ibn al-Haytham had a profound influence on European scientists, with his experiments being used by Roger Bacon and Johannes Kepler, among others. The Book of Optics was written in 7 books in the 11th century, but today only 2 Arabic copies containing books 1 through 3 exist. However, 17 complete or almost complete manuscripts survive of the Latin translation, De Aspectibus, which was more prolific throughout medieval and Renaissance Europe. Throughout the 12th century, the Book of Optics was distributed to libraries in Muslim Iberia, then known as Al-Andalus, which was a haven for different cultures and religions were able to freely exchange ideas, making it one of the intellectual capitals of the world at the time. This intercultural exchange enabled European scholars such as Italian translator Gerard of Cremona to visit these libraries in the 12th century and translate many works from Arabic into Latin, including al-Haytham's On Paraboloidal Burning Mirrors. More importantly, an anonymous scholar from Gerard of Cremona's translation house translated al-Haytham's Book of Optics from Arabic into Latin. However, this initial translation is rife with errors, as Stephens observes. The Latin translation of Kitab al-Manazir is far from perfect. Rather than quoting Ibn al-Haytham, the translator often paraphrases him. Because of the translator's lack of knowledge about optics, the paraphrase sections can be misleading. The translator also condensed the book by leaving out whole passages. There are also errors and textual misunderstandings in other translations. For instance, in the 1572 edition by Friedrich Risner, a German mathematician who invented the portable camera obscura. In section 24 of Book 1, Risner misunderstood the Arabic and wrote that Ibn al-Haytham admits the existence of visual rays when in fact he never does so. Unlike the egregious errors of the first translation, the following translations had several subtle errors, mostly regarding the nature of perception and its psychological considerations. Further compounding the issue of mistranslation is the lack of complete manuscripts in the original Arabic, so there are almost certainly errors in the Latin translation that we're not even aware of. Even the modern English translation from the Latin is also not without fault, as the translator is too often tempted to sacrifice strict rendering for the sake of improved style or varied and sometimes interpretative phraseology, according to A.I. Sabra. While this may not be an issue for most readers in understanding the text, it may result in obfuscating nuances of which a critical interpreter would want to be aware. There is also the problem of how widely read the Book of Optics was in Renaissance Europe. While Book 1 was well known and formed the basis of many European works on the subject of optics for centuries following its dissemination, the remaining books were little cited and relatively unknown. Book 1 contains information on vision and optics, while the following books are more concerned with visual perception. According to Howard, he anticipated many of the major theoretical and empirical advances in visual perception that have occurred in recent centuries. Ibn al-Haytham and the Book of Optics were undoubtedly influential on European mathematics and science, but when considering the mistranslation of the work and the neglect of many of its contents, many of the particulars of the work, and Ibn al-Haytham's philosophical perspective on the nature of optics especially, were lost in translation.
Okay, thank you. Okay, next we have a talk, our second talk for tonight. It is about House of Wisdom, which was an important institution, also a symbol of scientific progress in the Islamic world. So, yes, the presenters, please go ahead and introduce yourself and start presenting.
I'm Matt. I'm from Denver, Colorado, and I'm a senior.
I'm Anna. I'm from Wilmington, and I'm a sophomore.
And I'm Austin, and I'm from Indiana, and I'm a sophomore. Okay, so our talk is about the House of Wisdom, which was the intellectual center of the Abbasid Caliphate. So the House of Wisdom was an Abbasid institution. It was founded in Baghdad and centered there, which was the capital of the Abbasid Caliphate. We think it was most likely founded by the Caliph al-Mansur, who ruled from 754 to 775. But he used it as a library or a personal storehouse. And under the rule of al-Mamun from 813 to 833 is when the House of Wisdom truly was started. And we can't give an exact date for it because much of the information has been suppressed and hasn't been properly researched, which is just another example of the harm caused by the classical narrative that we heard about in the opening talk. So either way, it was founded somewhere in that period, and it served as the scientific hub of the Abbasid Caliphate, where there was translation, research, scholarship, and experimentation done, all the way up until the Mongol sack of Baghdad in 1258. And it's also important to note that there were tons of different fields of research going on, such as medicine, biology, physics, philosophy, but we're obviously just going to focus on some of the mathematical contributions that came out of it. So Al-Khwarizmi is the most well-known scholar who worked in the House of Wisdom. He lived right there around the starting date of the House of Wisdom. He's contributed to a bunch of different fields, but he is most well known for his mathematical contributions. He was called the father of algebra due to his book and his other contributions, and he also introduced the Indian numerical system to the Islamic world, which is the same number system that we use today. And his work, along with Al-Kindi, popularized it all over the West. So he's most famous for the Kitab al-Jabr wal-Muqabala, which was a book he wrote, which is seen as the start of algebra as a field. And in this, he created a new system of mathematics where he divided numbers up into three different groups, There was mal, which is x squared, roots, which is x, and just numbers, which are just constants. And he took these symbols and divided them up into 6 different quadratic equations. So for his book, the Kitab al-Jabr wal-Muqabala, this is the word al-Jabr, which was a mathematical function that he created, and it's from that we get the word algebra. As you can see, it's basically just adding a negative quantity to the different side of an equation, which is obviously done all the time in algebra. It's that which became the word algebra. And so these are the 6 equations that he created. As you can see, he's looking at basically equations as entire groups of problems instead of just single problems, where he would just divide it up into these 6 different groups. And then nowadays we don't really have these. We would just set it equal to 0 and solve it. But they didn't have the same conception of 0, where 0 was just a placeholder number for them. So instead they did it like this. And what's really important about his 6 quadratic equations is he wasn't looking at solving specific problems. He was looking at solving entire groups of problems. So for example, instead of trying to solve 5x equals 10, he would be looking at how do I solve an equation that's roots equal numbers, that first one you see there. And this is his most revolutionary contribution to math, where he's basically revolutionizing the way that problem solving and mathematical work is done. And it's because of this that the word algorithm comes out of his name, because he's developing this very algorithmic way to look at problems and solve them, where you want to solve an entire group of problems through a set group of steps instead of just figuring out individual solutions. So moving on from al-Khwarizmi, there were a ton of other Islamic scholars who worked in algebra and advanced his work after him. There was Thabit b Qura. He lived right after al-Khwarizmi, and he also worked in the House of Wisdom alongside him. He created geometric proofs for al-Khwarizmi's solutions to quadratic equations, which helped give further validity to his findings. And he's also really well known for the process called completing the square, which is a manipulation done to quadratic equations to make the perfect square so they're really easily solvable. And that's taught in every algebra class today. Another great scholar was Abu Kamil, who lived right after that. And he lived in Egypt, actually, but he had a copy of al-Khwarizmi's work. And he created proofs for all of al-Khwarizmi's common manipulations and made them much more proved, and created a further framework for algebra as a field. And then after that, there was Omar Khayyam, who he's most well known for creating the Rubaiyat, which is like a really famous set of poems you may have heard of before that was published in the West in the 1800s. But he also contributed to algebra by creating geometric proofs for al-Khwarizmi's work and then solving cubic equations geometrically. And then after all this work, obviously there was a ton of other work done in the Islamic world towards algebra and a ton of other scholars who we don't have time to cover today. This work was spread and extremely influential to the mathematical world. It was spread all over Europe. And out of the House of Wisdom, algebra can still be contributed as one of the most important mathematical fields. It is extremely important to all of life today.
So along with algebra, astronomy was a really important field to the scientists who work in the House of Wisdom. There was intellectual reasons because it was a time period in which people were really committed to furthering intellectual studies, but there were also religious reasons because astronomy was really helpful in figuring out problems like which direction to face when praying, or how to map out the Islamic calendar and figure out what dates important events fall on. Some of the notable Islamic astronomers from that time include al-Tusi, Abu Wafa, al-Battani, al-Kindi, Ibn al-Shatir, and more. And these are the people who contributed to the Western math that we know today, even if they don't know the credit. So an example from that was from our first talk where we heard about Copernicus and the work he used from Islamic scholars without giving them credit to build his heliocentric models of the sun. So like Austin mentioned, there are very few writings or preserved pieces of work that tell us about the history of a lot of these men, but al-Khwarizmi is probably the most well-preserved, so we're going to talk about his astronomy as well. A lot of his important astronomical contributions have to do with things that he wrote. So the first is a famous book called Zij al-Sintind. It's based on Indian astronomical methods known as the Sintind, and it contains tables for calculating the locations for the sun, the moon, and the 3 known planets at the time, which were Mars, Saturn, and Jupiter. So this book starts by focusing on the Metonic cycle, which is a Greek calendar. It's the calendar that's still used today to find Greek events like Easter. And then it moved into discussing the Indian methods for calculating the planets and the sun. So Zij is the word used for the actual table in all of these in this book, and there's 116 tables total with different astronomical and astrological data that hadn't been seen before that Al-Khwarizmi expanded on from other cultures that he was learning from. There are 37 different chapters in this book on calendar and astronomical calculations, as well as trigonometry tables like sine values and the first table of tangent values. And trigonometry is, of course, a really important field in math today. And this book dates near the very beginning of when it was first invented and when it was expanded on in the Islamic world. Al-Khwarizmi also wrote a book called Treatises on the Astrolabe. The astrolabe has instructions for how to construct an instrument called the astrolabe, which is a handheld version of the universe that can be used to track different objects in the sky based on the horizon. And it's a pretty simple looking instrument, but it was complicated at that time. And it's really important because it's still used today by astronomers and by navigators to figure out where they are. This book, Treatises on the Astrolabe, also has instructions on how to make a sundial, which is a really ancient form of telling time and one that was popular back then and is still really known today. The last piece of writing that we're going to focus on for astronomy is called Treatise on Extraction of the Jewish Era. And this is this one is the one that focuses on the Hebrew calendar and the Metonic cycle, and it also gives instructions on how to determine which day of the week each Hebrew calendar's first month lies, and it gives rules for determining the longitude of the sun and the moon using the Hebrew calendar. So looking at astronomy is a really interesting and important way to focus on how Islamic mathematicians were really innovative, but also how they were willing to collaborate with other cultures that came before them, like the Greeks and Jewish scientists, as well as Indian scientists. And we're going to talk next a little bit about geography, but just wanted to highlight how this work was really collaborative and how maybe that collaboration wasn't carried on after Western science became the main form or most popular form of science.
So for the last discipline, we'll be discussing medieval Islamic geography, specifically the work of al-Biruni. But before I get into that, I want to talk about just briefly two really important geographical scholars. The first is Ptolemy, who was an ancient Greek philosopher who had done a lot of the preliminary work in early geography by estimating and discovering longitudes and latitudes of nearly 8,000 locations in his book titled Geographia. This was super important because it was pretty much the baseline for all geographical works to come. And then the second is al-Khwarizmi, who saw flaws in the geography of Ptolemy, and his work was to correct a lot of those errors. And after correcting those errors, al-Khwarizmi expanded on Ptolemy's work even further, which made it easier for scholars like al-Biruni to complete the problems that he set out to complete. The House of Wisdom was immensely important in the discovery of many geographical problems and their solutions. For instance, the discovery of the circumference of the Earth, which was discovered by al-Khwarizmi. He used the distance between latitudinal lines to determine the circumference. It wasn't quite as accurate as later ways of doing it, but he did it. And then al-Biruni discovered and solved the direction of the Qibla problem by using spherical trigonometry, which was new at the time, but it required the coordinates that al-Khwarizmi found for Mecca and other already known places. So it's building on itself. And then also they were just continuing searching and estimating geographical locations of cities and oceans, for instance, and how big the oceans were and whether or not they were landlocked. And now we'll get into al-Biruni. Al-Biruni was one of the major medieval Islamic scholars who studied pretty much everything, including mathematics, geography, astronomy, physics, medicine, and history. Through his travels to India while accompanying Mahmud Ghaznavi, he was able to study the culture and people of India and wrote extensively on the subject, which gave him the title of the father of Indology, and his works are still cited today and used pretty commonly. Also, another really interesting thing that he did was he wrote a book on medicine and treatments, and it was pretty cool because it would fit in a book bag and it was kind of like the first field guide to medicine. Al-Biruni lived from 973 to 1084, and when he was only 17 years old, he was already calculating the latitude and longitude of his hometown of Khwarazm, which is in modern day Uzbekistan. By the time al-Biruni had turned 22, he had already completed many works, one of which was titled Cryptography, which was a mathematical projections book, pretty much just estimating the locations, similar to what Ptolemy was doing. And through his travels, al-Biruni, he left when he was 22 years old, or around 22 years old, and he met some of the greatest scholars in medieval Islamic world. And he discovered trigonometry, which is what I'll be getting into now, in two problems. The first problem is the problem of the Qibla, and al-Biruni discovered the sub-discipline of spherical trigonometry, which was the key to unlocking the Qibla problem. For this problem, al-Biruni used the coordinates of Mecca and other known locations to triangulate the direction of Mecca in relation to where you are. And this was totally revolutionary in the field of mathematics, and also allowed for the calculation of direction of Qibla in any known location. Another remarkable calculation that al-Biruni made was regarding the estimation of the radius of the Earth. He accomplished this again by using trigonometry, and al-Biruni solved this through the angle formed by the top of a mountain related to its horizon. So the first step he took was to calculate the height of the mountain, for which he used an astrolabe, which Anna just spoke of. And the second step was to find the angle of the dip, which was what the arrow is pointing to on the PowerPoint in that figure. And then the third and final step was to just apply his trigonometric rules to find the radius of the triangle that he had constructed based on the measurements of that he had taken using his astrolabe. And it was extremely accurate. His calculation actually only has 1% of error compared to the modern calculation of the radius of the Earth. And lastly, we'll go into the legacy of the House of Wisdom. The House of Wisdom is really important as a historian who's studying the times, because it provides a timeline that disproves the classical narrative that was stated in the opening presentation, because the establishment lasted much longer than al-Ghazali, with most of the really important scholarship coming after that. And so it just disproves that kind of classical narrative. It also had a major influence on the European Renaissance because it was able to record vast amounts of information and collect a lot of the information that was being produced at the time. And on top of that, it was able to preserve all of these works. And so they were able to make their way into the hands of people like Copernicus. And finally, in conclusion, it is important to understand that the House of Wisdom is an idea that's stretched far beyond the physical library or physical conservatory of the House of Wisdom, or the house. It was never, there's no physical proof of it existing, but I think it's really important to just think of it as an idea, because it was so integral to the mentality of the Islamic scholarship greater. Yeah, so thank you so much.
Thank you.
Thank you.
Okay, thank you, Matt, Anna, and Austin. Okay, so next we have two videos. The one we are going to see next talks about the relationship, particularly between Islamic faith and scientific discoveries by Muslim scholars. So, okay, Gavin, Joe, and Andrew, go ahead and start your presentation.
Okay. Hi, everyone. My name is Gavin. I'm a first-year student at Kenyon. I use he, him pronouns. I'm from East Greenwich, New York.
Oh, Gavin, your audio was broken to me.
I'm Andrew. I'm a sophomore. I use he, him pronouns, and I'm an international studies major.
Hi, I'm Joe. I'm a sophomore, and I am a English major who uses he, him pronouns.
Can you hear me now?
Yes, it is better now.
Okay. Hi, everyone. I'm Gavin. I'm from East Greenwich, New York. I use he, him pronouns, and I am a first-year student. And I cannot hear you all. I think I can now. And our project is called Islam's Imperative Influence. It is about the religion of Islam and how some of its customs that came about in the medieval Islamic times. Mathematicians used these customs as a basis to determine, they used mathematics to help solve these issues and help their religion grow and help their societies. And then as a basis, how we use that math today. So enjoy the video.
Advancements in mathematics and science often result from practical applications to communities. This is no truer than in the medieval Islamic world. Many commitments of the Islamic faith required implementing mathematical concepts and calculations. Scholars of the time recognized this and developed monumental discoveries from their findings. We'll take a closer look at the three areas where Islam's influence on progress in mathematics is evident: inheritance, zakat, and qibla. Inheritance, known then to Islamic scholars as al-Faraid, refers to calculating inheritance for next of kin after a loved one has passed away. One of the first scholars to develop the mathematics of inheritance laws was Muhammad ibn al-Khwarizmi. In his 9th century work, the Compendious Book on Calculation by Completion and Balancing, he devotes a significant portion to the calculation of al-Faraid. He even states within the text that this topic's importance was a key motivator behind his work. These calculations were quite simple at their base. Strangers could receive a gifted amount up to 1/3 of the total, followed by portions for one's surviving spouse and children. Daughters were only given half as much as sons, which, while unequal, acknowledged their familial role in an unprecedented way historically. Today, the rules of inheritance have evolved. The rules are not as standardized as they were then. However, the mathematics of algebra and proportions behind the inheritance laws are now imperative to nearly every mathematical discipline. Many discoveries led by al-Khwarizmi and scholars after him are now taught as fundamentals of the mathematical curriculum to millions of young adults worldwide. Another Islamic tradition with mathematical roots is zakat, the yearly tithing Muslims give towards charitable causes. An early scholar in calculating zakat was the 11th century scholar Abu Mansur al-Baghdadi. In his work, he pioneered a novel method to work through and number one place value at a time, finding quick and accurate calculations, taking 1 in 40 of a set of number. His innovation included a conversion between base 40 and base 60 number systems to make calculations easier. Currency in medieval Islamic societies were split into dirhams and flus, with 1 dirham equal to 60 flus, which is why this conversion was helpful. His method could find the required tithing in seconds and could be repeated with any number for as many times as needed. The zakat calculations revolutionized by medieval scholars continue to be used worldwide. In many Muslim-majority countries, zakat's calculation is essential not just for individuals, but for tax systems and deductibles led by entire governments. Al-Baghdadi's work was an early precedent for managing billions of dollars today as part of a commitment to Islam's teachings. Qibla refers to the direction all Muslims must pray towards during their daily prayer. All Muslims face Mecca in the direction of the closest distance between Mecca and their current location. This was a brand new problem for Muslim scholars, and its solution required sophisticated new mathematical ideas. Using mathematical calculations with azimuths and spherical trigonometry, Islamic scholars were able to calculate Mecca's position as it related to an observer at any point on Earth's surface. They used common functions of trigonometry further developed by the scholars themselves. Trigonometry also allowed for a more accurate revision of many earlier works. With these methods, an understanding not just of Mecca to observers was created, but also the Earth's shape and size and relative distances and directions between people at 2 points. Many ideas in trigonometry are now vital to fields across science and mathematics, including modern navigation. The developments behind inheritance, zakat, and Qibla demonstrate the lengths that Islamic scholars were willing to go to for their religion and for their neighbors. Not only was there no conflict between religious beliefs and science in Islam, but religion played a key role in development of many scientific disciplines in the Islamic world. These discoveries were vital to the upkeep and function of many important facets of life that people in their time encountered. Medieval Islamic mathematicians and scientists combined their dedications of faith and science to find consequential discoveries that would go on to change the lives and practices of mankind.
Okay, great. Thank you all for watching and enjoy the rest of the presentations.
Thank you, Gavin, Andrew, and Joe. So now we are ready to see the next and the final presentation, which is about a field of information theory, which is so vital to modern world, and for which a medieval Islamic scholar made significant contributions. So, Ricky, Isabel, and Dylan, please go ahead and start your presentation.
Hi, my name is Dylan. My pronouns are he, him, and I'm a sophomore economics major.
My name is Brookie. I use she, her pronouns. I am a junior and I am a music and modern languages major studying Spanish and French.
And my name is Isabel. I use she or they pronouns. I am a sophomore who is majoring in women's and gender studies.
So our video is on cryptography and cryptanalysis, and we look at one scholar in specific whose name is Al-Kindi, who had a major impact on these fields. And the video will pretty much just explain what cryptography and cryptanalysis are and show who Al-Kindi is and how he impacted the field.
Have you ever wondered how complicated coded messages are solved? Or how information on the internet is stored and transmitted securely? Well, it turns out that these two things are connected through a science called cryptology, also referred to as cryptography, and the related field of cryptanalysis that can be traced way back to 9th century Islam, and one man in particular. In this video, we'll touch on the basics of cryptology and cryptanalysis, their history and emergence in the Islamic world, and their relevance today. What is cryptography? The need for confidentiality in the delivery of information has been important throughout history and continues to be relevant today. History as we know it has been largely based on the successes and/or failures of confidential information reaching its intended recipient. Given the importance of concealing and sending private information, the science of cryptography came about. Cryptography is a method by which a message may be altered so that it becomes illegible and meaningless to anyone else but the intended recipient. Cryptography kept important information hidden from enemies for centuries. Most efforts of breaking these encrypted messages were futile. This led some to believe that these coded messages may be divine. However, this all changed thanks to the work of the 9th century Muslim scholar Abu Yusuf Yaqub ibn Ishaq al-Kindi. Al-Kindi was born in Basra, modern-day Iraq, around 800 AD, in a time of great intellectual curiosity in the Arab world. He is well known in history as a philosopher and mathematician, and produced many works and letters ranging across various topics such as philosophy, optics, math, sciences, cosmology, astrology, medicine, psychology, and music. Al-Kindi worked as a calligrapher in the legendary House of Wisdom under Caliph al-Mamun. The House of Wisdom was a hub for the collection of knowledge of all kinds, and part of the work done there was translating foreign books filled with information. Some of the works that came through the House of Wisdom were encrypted, which spiked Al-Kindi's interest and drove him to pioneer the field of cryptanalysis, the science of deciphering coded messages. Al-Kindi's famous method of cryptanalysis can be found in what is known to be the oldest book on cryptography, his work, A Manuscript on Deciphering Cryptographic Messages, from 841 AD. In this treatise, he explains his method, which is called frequency analysis. When the original language is known, frequency analysis is done by, firstly, finding a page of a different plain text of the same language as the cryptogram, counting each letter and measuring the frequencies of each letter. The first most frequent letter is referred to as first, the second most frequent as second, then the third most, third, and so on, until all the letters in the plain text are accounted for. Next, you calculate the frequency of the symbols or letters in the cryptogram. Then, you replace the most frequent cryptogram symbol with the most frequent plaintext letter, the second most frequent cryptogram symbol with the second most frequent plaintext letter, and so on until all the symbols in the cryptogram are replaced. This groundbreaking technique is the first recorded explanation of cryptanalysis and is what led Al-Kindi to be known as the pioneer of cryptography. Al-Kindi's method of frequency analysis has been widely used since its inception, and many other methods of cryptanalysis have been developed. The field of cryptology has a special significance in today's day and age, as it is pervasive in the security aspect of the internet and technology. Cryptography is used today for authentication online, emails, online banking, integrity checking, playing games of chance, cryptocurrencies, and more. This is another example of a modern scientific field whose roots lie in the medieval Islamic world, where the history is not broadly known or recognized. Al-Kindi's groundbreaking work pioneered a revolution in decryption, and his story is just beginning to be retold today.
Okay, thank you, Dylan, Furuki, and Isabel, and all of the students who presented tonight. So this is the end of our formal presentations. Now we can take questions.
Hello, everyone. Thank you so much, Professor Aydin, first of all, and to all the students for putting in all this effort. I definitely learned a lot, and I'm sure the audience on all platforms has learned quite a bit of information as well. The first question that we're going to start off with in this Q&A session, also shout out to the audience. The engagement in these questions has been amazing. Keep them coming, and we'll be here to answer them. So the first question, I think it's really important because it pertains to why all the information we learned today is important. So Professor Aydin, how, why, and where would you use the knowledge that we learned today about Muslim contributions in STEM?
Well, okay, regardless of where and how you use that information, first of all, we need to make sure that we are learning correct information. So that is our primary goal. And for the most part, people do not learn accurate information in school. And the next question, I mean, we cannot really, we are not at that level yet, right? So most people are not learning accurate information in school. first we need to make sure that that is happening. Then we can think about where and how to use that information, right? So just like, there is this principle, before you have an opinion about something, you need to have the basic facts right. So we are not at that point, right? Most people not learning accurate information. And we first really need to focus on that, right? And there is a lot of work, effort that needs to be done. Just because a few people know about it is not enough, right? And very highly educated people throughout their education from kindergarten to PhD level, they don't get access to this accurate information. So that is the first thing that we need to address. Then what we are going to do with that information is the next step, okay? We are not there yet. So that is my take on this, question.
Now, moving on to the next question, it pertains more to the content of the class. Is Edward Said and Orientalism a big topic within your class?
No, because this is primarily a math course, and actually most of the course is actually about the actual math content. That's about 65% of the course. The rest is, this history content, and in which we primarily discuss, these two narratives. So, there is so many aspects of this topic that can be discussed, but that is not, we don't have really space in this course. So we don't discuss Edward Said and Orientalism, not in a direct way, but when we talk about classical narrative, it is kind of indirectly part of it. But keep in mind, this is primarily a math course. Actually, most of the time we spend on actual math, which is on arithmetic, geometry, trigonometry, and algebra.
Well, that's more informative. I was actually interested in that too, so I'm glad you answered that. Now this question is more pertaining to the students, but Professor Aydin, that is up to your discretion. Did you need guidance finding the resources used in your presentation, given that the scarcity of representation in mainstream media or in lack of information in current curriculum in education?
So I like, students to answer this. So I definitely, if you look at the course website, so even though the research is incomplete in this field, there is still plenty of materials, fair amount of materials. And if you check out, some of the websites, you'll see, I gave a lot of starting points for many different topics in this field. And I like to hear from my students whether, there was enough materials to start their projects. So maybe at least, actually, I would like to hear from most of the groups or all of the groups how useful it was, the materials that I provided.
I can answer that. I think we didn't really have that much trouble finding material on it, but I think the one issue that we encountered was a lot of the material that we were finding was by the same maybe 4 or 5 authors. So I guess just the diversity in scholarship, I guess, would be one issue that we found. But there is actually a lot of material out there. So if you want to go look for it, it's out there.
Yeah, to add on, I'm mostly interested in the linguistic aspect of history and finding sources in English, which is the lingua franca of modern academicism, while widespread is not as widespread as it could be. There are many books and original manuscripts that have not been translated to English. Professor Aydin is trying to help that effort right now by translating the Miftah al-Hisab, and he's doing a good job of it. But I think there could be more efforts in addition to those like Professor Aydin's. I ideally would want to work in a field like that. I've been studying Latin and Arabic, hopefully to further the knowledge of such manuscripts. But in the end, it's a concerted effort that should be made by more people, I think.
Yeah, there's definitely not as much research out there as on a European Renaissance. era scientists like, say, Copernicus.
Mhm.
But there's definitely an ever-growing body of research on this information.
Yeah, once you cross the cultural divide, you see a stark difference in the amount of not only primary, but also secondary and even tertiary information on a single subject. It's not surprising, but it's disappointing. So the more we can get out there, the more we can will definitely accurately represent Islamic contributions to math and science.
Yeah, I can say a word on this too, if you'd like. Yeah, it's definitely from our research. It's definitely, for one, it's a minority of sources that get the alternative narrative correct and that have been preserved, especially primary sources, for so long. And then also with the language barrier, it's even more difficult. But thankfully, in recent years, because of professors like Professor Iden and many of his colleagues in universities across the world, we are starting to get new secondary resources and analysis on like some of these concepts. And then we're also beginning to be able to translate more primary sources and uncover them from lost archives and records that had been hidden for centuries. And now, especially with the internet too, we have access to enough information that I think anybody who's interested could get a pretty solid understanding in the topic, even if it isn't terribly well known.
To add a little bit on that, I think it's pretty interesting. Like, I myself was really shocked at how recent information can still be very wrong. We've seen textbooks from like the mid to late 2000s into the 2010s that still publish things that are just blatantly inaccurate, and that, given plenty of other sources that are available, it's kind of egregious how they're able to still get away with publishing these, especially with like well-known like companies and publication corporations. It's pretty interesting to see how they're still able to continue the classical narrative that we've talked about.
From a slightly different perspective, I think a lot of the mathematical language that is in a lot of these sources that we're reading off of the databases is in language that's both very different, because it doesn't include a lot of like the standard mathematical proofs that we're taught to read in some other math courses. We have a course at our school on proofs and proofwriting, and it was unlike anything I've ever seen before. And it's also just like way above like undergraduate mathematical understanding, and therefore way above like, a high school or a middle school or somebody much younger than us trying to learn how this math was done and how to understand what's happening. So while the information is definitely there and there's an abundance of it, it's not necessarily very accessible, I would say.
I also like to hear from the group who worked on al-Kindi. That was a very specific topic. So Dylan, Bricky, or Isabel, how do you feel about, finding resources on this topic?
I don't feel like we had too much trouble finding material, especially with the resources that you gave us.
Yeah, I think
I feel like the problem is more that the material isn't really widely taught. I think the material's out there, but it's just not a subject that's taught very often.
yeah, it takes some time to actually find it, like the links that we started with, looking through their bibliographies and what sources they used, because some of them came from like larger works based on coding and sorts of stuff like that, and they only have a small section dedicated to the influence of al-Kindi or other Islamic mathematicians on these topics.
And there is one more thing I would like to add, which is al-Kindi's manuscript was only studied by research, or came to the attention of researchers in 1980s. And that manuscript was in Istanbul, in a library in Istanbul. Yet another example of such manuscript. So al-Uqlidisi's unique manuscript was also in a library in Istanbul, and it was only studied in 1960s. That is really late in the history of science in the grand scheme of things. That is another, there are so many manuscripts in Istanbul that have been ignored for so long. That is one of the things that made me really compel, that made me disturbed and compelled me to do something about this field. They're just coming out, and who knows how many more manuscripts are there. I know that there are many more waiting to be studied. The fact that Al-Kashi's book has not been translated to English until now, and a person like a beginner person like myself, who did not, whose expertise and training was not in this field, the fact that it was up to me to do this is quite telling about, the great need for research on primary source materials. There is like tons of materials still waiting to be studied.
Thank you all for the insightful answers. It's interesting to see that there's so many resources available, yet maybe a little bit out of reach due to translation and something. But I really appreciate the student input as well as the professor's input. Moving on to the next question, I would also appreciate student input on this one as well. So was it a surprise for you when you learned that the Islamic faith and science were synergistic and inseparable?
Yeah, I can speak on this because that was a big focus of our video and of our research. So I guess a conventional narrative both in the classical narrative and just in history classrooms in general is that religion and science are in conflict and that they don't get along, and that it's like oil and water. You can't have both. And I think a lot of that, as we learned, a lot of that narrative comes from Christianity and from the Byzantines around the same time as medieval Islam, but because their science was frowned upon and thought as against God. But as we came to learn over the course of the semester, and especially as we were doing our research, is that science was seen as key to Islam, as a way to improve it, and as a way to dedicate oneself to religion while also improving society through these new concepts in science and mathematics.
Anyone else who would like to add to this point?
I thought Gavin said it wonderfully. Sorry.
No, go for it. Go for it.
No, I thought Gavin said it wonderfully. I thought he really was cogent on this one.
Just one more. Yeah, just one more thing is, and Gavin kind of brought this up already. Yeah, well done, Gavin. But yeah, I think because a lot of this research that we're reading and these narratives are very Eurocentric. I know in European history there is a tendency for there to be a conflict between Christianity and the sciences, and the European historical narrative essentially tried to transplant what happened in European history between religion and science onto Islam and science, which as we now know was not the case, that the two could go hand in hand.
Yeah, even propelling one another, as we see throughout many of the equations we see throughout the text from the class.
Thank you so much for all your input. We are trying to conclude by 9:30, so I do want to appreciate your time. And we have 3 great questions left, so I do want to get to all of them. So the next question is, did Muslims give proper credit to the previous societies when they published in their fields during the Golden Age? We see that Europeans did not give proper credit to Muslims during the Renaissance. So what was your experience with that?
If the students want to say something about it.
From my understanding, very much so, because a lot of the publications at the time were translations that were then built upon. So it was like a translation of a section of Euclid, and then the writer would go much further into depth and contribute quite a bit to the field. So you knew exactly like the history of said math or science, and then how they built upon it. That's how the text described these developments.
I also think that one thing that we kind of touched on a couple times during the course was that part of the reason why Islamic scientific advancements were not really cited so well during the European Renaissance was the fact that it was kind of known as common knowledge by that point. And so some of those things may have still happened during the medieval Islamic period that we've been researching, some of these things having been considered common knowledge that may not have been cited, but I do think we saw a lot of instances of people saying, this was a Persian science, or this was like a lot of it was working on Greek sciences, and that was very explicitly like, this is me working on Greek sciences and improving it. So I think there was probably a little bit of both there.
One of the biggest things was like one of the biggest narratives surrounding most of the scholars we talked about was that like the classical narrative says that they simply translated and preserved works. And I think it's kind of ironic because they were often given like a weird amount of credit for what they did in preserving and translating, but not on like what they did to build upon it. It's kind of like a weird dichotomy between they were given the proper credit and they gave proper credit, or sorry, they were not given proper credit for what they did, but they did give proper credit, if that makes sense. It's kind of like a weird progress of what they did and didn't do.
Thank you so much for the insight. The next question is more related to the topics covered. One specific, the House of Wisdom. So the House of Wisdom has been mentioned in frequent presentations. If you were to find a parallel for it in modern times, what would it be?
I would say a historical parallel would be the Library of Alexandria, which I think functioned in a really similar way, and similarly much of the work was lost. In terms of modern parallel, nothing immediately comes to mind.
This is a bit more interpretive, but you could almost say that like the internet is a similar place, just because it's like, if you look at like the intellectual sides and like the ways that you can connect people across different cultures in the internet, I think that like scholars of that time would have been really excited by a feature like that. And I think that it sometimes promotes like the same collaboration that the people who lived in the House of Wisdom were really excited about.
To me, it would be like a research institute funded by the government. So yeah, to me that is a pretty good parallel.
Great. Well, and now moving on to our last and final question, Professor Iden. This is more directed towards you. It's already been answered in the Q&A. However, I just wanted to add a little piece to it, and I feel like the entire audience can benefit from it. So if someone were to follow in your footsteps behind the mission of disseminating accurate information, did you face or do you foresee pushback or negativity that was presented to this alternative narrative or like the accurate truth, especially in the academic circles? And if you haven't experienced any pushback, if someone were to face pushback, how would you recommend that they go about it?
Right. Yes. For the most part, no, I did not get much pushback from academics because, my goal and purpose and focus is on facts and primary source evidence. What we are challenging is not based on primary source research. And, I'm really trying to be very careful, not to make claims that are not based on factual, evidence based on documentation. so you may get pushback, when it comes to interpretations, I mean, so there is facts and then there is interpretations. And we need, just like the news, right? We need to be careful to separate and distinguish between actual facts and then their interpretations. So maybe, again, in terms of actual research evidence, I mean, cannot really, there can be no pushback on that. But when it comes to interpretations, maybe sometimes a little bit, including some Muslims, I can say. But for the most part, no, I don't get pushback. But my biggest advice would be to distinguish between those two things, right? What are the facts, and then what do we do about them, and then how to interpret them? That is the next level. That is the next question. And we really need to be careful to distinguish between them. Yeah, so.
Thank you for your insight. I was personally interested because I very much appreciate the truth. Going to law school, that is the plan, to disseminate the truth and nothing but the truth. But before we come to an end, I just wanted to give an opportunity to the professor and all the students in presentations today, if you would like to say last words or anything to leave the audience with.
I mean, if anybody, student wants to say something, please go ahead and say so.
Thank you so much for coming.
And I really would like to repeat the two great needs in this field, which is those who are more academic types. The research on primary sources is a big need in this field. There is tons of manuscripts that are waiting to be studied all over the world, Muslim world, and even there are many manuscripts all over Europe, for example, which is really curious. And also there is a great need in terms of dissemination of academic information that is already established. So just because something is academic knowledge doesn't ensure that it becomes common knowledge. And especially, in order for it to be common knowledge, it really needs to be part of the school curriculum. And that is also a great need. And Muslim community and everyone who's concerned about this, they can do something, towards this goal. And and again, we are making an effort to make materials available for school curriculum for teachers and students. Again, some of these links are here, and this is really a big need. And I would like to draw attention to this need as well. Thank you.
Well, if there are no further comments, I would like to bring it to a close. But first of all, a huge thank you to Dr. Aydin and all the students who took time off of their weekends to share some information with us. We wish you the best of luck in your finals and hope that your winter break is restful and full of joy. I would also like to thank all the audience members on all of our platforms for tuning in. The engagement was amazing, awesome questions, and we got insightful answers. And this event wouldn't be done without you. So please keep NICC in your best wishes and include them in your charity. I encourage you to check our social medias for upcoming events, including a webinar titled Faith and Mental Illness Can Coincide on Sunday, December 12th. And our final annual banquet is on December 18th. May you all be blessed with a safe and joyful winter break full of happiness, health, and family. Assalamu alaikum wa rahmatullah.
Thank you.